We're ready to tackle Unit 8, and Unit 8 involves something called the Pythagorean Theorem. And in order to do well with the Pythagorean Theorem, we need to be really good at working with perfect squares and then finding square roots, simplifying square roots. So I know you've seen this before, but the instructions here say complete the first column, then use the answers to complete the second column. I'm going to do that down to a certain point here. I'm going to go down to 12 squared. But remember, when we square something, the exponent tells us how many times we use the base as a factor. So when we write 1 squared, it literally means 1 times 1. So the answer on that one is 1. This would be 2 squared, so that's 2 times 2. This is 3 squared, so that's 3 times 3. Again, notice we're not multiplying the base by the exponent. The exponent is telling us how many times we use that base as a factor. So this would be 4. This would be 9, 16, 25. These are things that we should have memorized. These are in our times tables. Whoops, let me make that look like a 64. 81, 100, 121, and then 144. You should definitely have memorized down to there. And then if we come over here and we use these numbers to find the square roots, remember, if we square something, it changes one factor into 2. So 1 squared was 1 times 1. Taking a square root does the exact opposite. It takes 2 factors and turns them into 1. So we've got 1, square root of 1 is 1. Square root of 4, that would be 2 2's, so we get a 2 on the outside. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36. And again, let me show you why this works this way. This is 6 times 6. There's a pair of factors, so there's a 6 on the outside. Technically what's stuck underneath is a 1, but the square root of 1 is 1, so we end up with just 6 times 1, which is 6. So that's why the answer works out the way it does. You don't have to think of them this way, but it is helpful in the long run because we're going to be simplifying some of these in a few minutes. And then we've got 49, 64, 81, 100, 121, and 144. And again, if we take a look at this, here's what happened. We took 12 and we squared it, we got 144, and then we took the square root of 144 and we got right back to 12. So whatever squaring does to 12, taking the square root of that answer, it undoes it and we get right back to 12. That's that whole idea of inverse operations, really valuable. And then I'm hoping that you've got a bunch of these memorized. So 13 squared would be 169, 14 squared, 196, 15 squared, 225, 16 squared, 256, 17 squared, 289, 18 squared, 324, 19 squared, 361, and 20 squared would be 400. And then we can go through and we can take each one of these and we can put them underneath the square root. So the square root of 169 is 13, square root of 196 is 14, square root of 225 is 15, 256, 289, 324, square root of 324 would be 18, 361, and then the last one, of course, is 400. Okay, now the question here is, do you remember how to simplify square roots? Well, I just gave you a reminder of that. What we're looking for is we're looking for pairs of factors. So a pair of factors on the inside makes one factor on the outside. And to do these problems, if you need to do a factor tree, by all means go ahead. So on this problem right here, the way we got the 3 times 3 times 5 so we could identify the pairs is this is 9 times 5. And that's 3 times 3. So there are the prime factors. So we put those underneath there. And then we're looking for pairs of factors. Pair of 3's on the inside means we've got 1 on the outside. So a radical 5 left outside. 72, we can do it this way. 8 and 9. 3 and 3. 4 and 2. 2 and 2. So we've got 3 2's and 2 3's. So there are the 3 2's and then the 2 3's. Pair of 2's, 2 on the outside. Pair of 3's, 3 on the outside. The 2 stuck underneath because we don't have anything to pair it up with. So we have 2 times 3 on the outside. That's a 6, and then radical 2 here. Now, we are going to check this on the calculator. So I'm going to bring up the calculator. And when we use the calculator to check and make sure that we've simplified correctly, here's what we're going to do. We're going to put in the original problem. So we're going to do the square root of 72. So I'm going to hit second and the squaring button above there. That's that square root. No coincidence that they're on the same key. There's the square root of 72. Again, hop outside, hit enter. We end up with 8.485. And then we're going to plug in the simplified answer. So that's going to be 6 square root 2. Hop outside, hit enter. 8.485. So we know that this original problem right here matches what our simplified answer is. And you can do that anytime you need to if you want to double check and make sure that you did it right. But I'm hoping for most of these it turns out to be pretty easy to do. So take a look at this next problem here. We've got square root of 25. That's a pair of 5s underneath there. Now if you wanted to think of it this way, that's totally okay. If you just wanted to write the square root of 5, square root of 25 is 5. That would be okay. 169, of course, that's 13. We did that one up above. Square root of 18, this would be 2 times 9, and that's 3 times 3. So we can write this as 2 times 3 times 3. Pair of 3's here, 3 on the outside and then a 2 underneath. We can circle that and say we're done there. You can also right here, if you can see that you've got a pair of 3's here, and then that you don't have anything to pair the 2 up with. If you wanted to do that, that's totally okay. If we take a look at this one, this would be 3 times 25, 5 times 5, pair of 5's, so you've got 1 5 on the outside, 3 stuck underneath. And then let's take a look at this 1024. So I'm going to grab the calculator. I'm hoping this works out well, but I'm going to use the calculator to kind of factor this. So let's take a look. So I'm going to clear this off, and we're going to put in 1024, and I notice that's even. It ends with a 4, so I'm going to divide by 2. Hit enter. That would be 512. I'm going to divide by 2 again. That's going to give us 256. That's still even, so I'm going to keep dividing by 2. Unless that's something that you recognize, I'm going to go ahead and divide by 2 here. 128. Divide by 2 here. Yeah, we could keep going with this, but here's what I'd like you to notice. When we went through and we divided by 2, that was 512, and then this was, let's see, this was 256. We could keep going with this and keep breaking this down further and further, but I'm hoping that you recognize this number. 256 is a perfect square of 16. So this is a pair of 2's, and a pair of 16's. So if I were to write that out and we took out the pairs of factors, I'd have a pair of 2's and a pair of 16's. So I'd have a 2 on the outside, a 16 on the outside, technically a 1 left underneath. So the answer on this one should be 2 times 16, which is 32. So I'm going to circle that. Let's come back here and check and make sure that that's right. There are 2 ways we could do this. One way we could say, well, we think we know the answer, so let's just square that. And it's 1024, so we're in good shape there. We could also go ahead and throw the square root in there and just, double check and make sure that the square root of 1024 is 32. So we got the answer right there. All right, now let's flip over to the other side. These problems, it says simplify each square root, so a lot of these are not going to work out perfectly. You're going to have radicals in the answer, so you're going to put them in radical form. Please don't use decimals. So if we were looking at an example like number 4, we would probably do 6 and 4, 2 and 3, 2 and 2. And again, if you wanted to write it out like this, 2 times 2 times 2 times 3, so we've got the 3 2's represented and then the 3. Pair of 2's, 2 on the outside, 2 and 3 left on the inside, so that would be 2 radical 6. So we'd be done with that one right there. You could also just recognize, hey, if I've got these all factored and I can see what these prime factors are, there's my pair of 2's. Nothing to pair those up with, so we could get the answer that way also. If you did want to check, let's just make sure that this worked out right. Let's type in the square root of square root of 24. Hop outside, that's a good habit. 4.898, and then let's do 2 square root of 6. Hop outside, hit enter. 4.898. So we got that one right. If you want to use your calculator to double check, that's fine, but please don't write down decimal answers. We want these simplified in radical form. These are exact answers, and that's what we want. All right, good luck with the assignment.